the James Webb Space Telescope is once again demonstrating its remarkable capabilities. As the most powerful space telescope ever built, Webb is homing in on the deepest secrets of the cosmos while providing us with spectacular images that reveal the structures of the universe in unprecedented detail. Although these formations are often several million light-years away, the razor-sharp Webb images make them seem as close as your fingertips. The first spectacular snapshot reveals that Webb's view of the stars can sometimes bring unusual or strange objects to light. If you ask us, it looks like Webb has captured a glowing penguin and its egg in the vastness of space. But ask an astronomer, and they will explain that this image shows the pair of galaxies ARP-142, located about 326 million light-years away, which have been performing a close dance in space for quite some time. These two galaxies, located in the constellation Aquila, have been merging for between 25 and 75 million years. This fate also awaits our Milky Way and the Andromeda Galaxy in a few billion years. However, ARP-142 consists of an elliptical galaxy and an irregular galaxy, unlike the spiral Milky Way and Andromeda. The irregular galaxy, NGC 2936, has formed impressive tidal arms as a result of its interaction with its elliptical partner, NGC 2937. Webb's false-color infrared images make it appear as though NGC 2936 is throwing cosmic confetti. The colossal gas and dust clouds are accompanied by a high rate of star formation, with around 200 new stars born every year, significantly more than the 6 to 7 stars formed in the Milky Way annually. However, the distance between the galactic pair is currently around 100,000 light-years, so it will take hundreds of millions of years for the two structures to merge. While Webb's recent images of the pillars of creation are breathtaking, the structure was first captured by the Hubble telescope in 1995, with more precise images following in 2007, 2011, and 2015. But none of these images compares to the ones Webb presented to the public in 2022. Webb's infrared capabilities reveal structures that were previously invisible. The reddish balls seen at the ends of the pillars are newly forming protostars, and the curved, lava-like lines represent the rays that young stars in their cocoons regularly hurl at the surrounding cloud material. NASA recently published a new combined view of the pillars of creation that merges Webb's infrared data with Hubble's visible light images, offering a comprehensive picture of this star-forming region. Although Webb is primarily known for exploring the most remote and oldest structures in the universe, it also takes time to observe our solar system. Recent images of Jupiter, the gas giant, reveal details never before seen by the human eye. Using different filters, Webb captured infrared radiation from various wavelength ranges, translating them into visible colors. These images showcase not only familiar features like the Great Red Spot and auroras but also delicate rings and tiny moons, Adrastea and Amalthea. Webb also took the first direct image of the super-Jupiter Epsilon Indi b, located 12 light-years away. This exoplanet, with a mass 6 times greater than Jupiter's, is the coldest and oldest exoplanet imaged directly. With an age of about 3.5 billion years, it is much older than most other directly imaged exoplanets, which are typically younger than 500 million years. Researchers hope to use Epsilon Indi b to test models of planetary evolution and explore late-stage exoplanet development. Supernovae are among the most powerful events in the universe, marking the end of a massive star's life. Webb recently captured a high-resolution image of the supernova remnant Cassiopeia A, Cas-A, located 340 light-years away. Webb's near-infrared view reveals the remnants of the star's explosive death, including filaments of sulfur, oxygen, neon, and argon. The bright orange and pink glow marks the inner shell of the remnant, while a white glow shows where the supernova shockwave is colliding with the surrounding material. A curious structure named Baby Cas-A, likely a glowing dust field heated by the supernova shockwave, also appears in the image, though it is actually 170 light-years away from Cas-A itself. The James Webb Telescope recently revealed new details in the Serpens Nebula, located 1,300 light-years away. It detected protostellar outflow jets, gas jets from young stars that interact with surrounding gas and dust, all pointing in the same direction. This discovery supports the theory that young stars rotate in the same direction when their gaseous birthplaces collapse. In previous images, these jets appeared blurred or invisible, but Webb's high-resolution capabilities have brought them into clear view. The first snapshot reveals a delightful twist. Webb's technical prowess has brought an unusual image to light. If you ask a casual observer, it may appear as though the telescope has captured a glowing penguin and its egg drifting through space. However, astronomers would tell you that the image in question actually features ARP-142, a pair of galaxies located about 326 million light-years from Earth. These two galaxies, situated in the constellation Aquila, have been engaged in a gravitational dance for the last 25 to 75 million years. This galactic interaction is of great interest because it foreshadows the future collision between our own Milky Way and the Andromeda Galaxy, an event anticipated to take place in a few billion years. However, unlike the spiral nature of the Milky Way and Andromeda, ARP-142 consists of an elliptical galaxy and an irregular galaxy. Irregular galaxies, as their name suggests, lack the symmetry and well-defined structures of their spiral and elliptical counterparts. In this cosmic ballet, the irregular galaxy NGC 2936 is being shaped by the gravitational forces of its partner, the elliptical galaxy NGC 2937. The result of their gravitational interaction is the formation of stunning tidal arms, vast extensions of stars and gas that have been stretched out. In Webb's false-color infrared image, it appears as though NGC 2936 is tossing cosmic confetti into space. The vivid gas and dust clouds, captured by Webb's infrared detectors, highlight an area of intense star formation. While our Milky Way gives birth to about 6 to 7 new stars annually, the rate in NGC 2936 is much higher. Around 200 stars are born every year. However, despite their gravitational attraction, these two galaxies still have some distance between them, approximately 100,000 light-years, roughly the diameter of the Milky Way. It will take several hundred million years for them to fully merge into a single new galactic structure, giving us a glimpse of the future fate awaiting many galaxies in the universe. Few celestial objects have captivated the public imagination as much as the Pillars of Creation, located in the Eagle Nebula, around 7,000 light-years from Earth. First imaged by the Hubble Space Telescope in 1995, these massive columns of gas and dust are a stellar nursery, where new stars are born. While Hubble's initial images were iconic, subsequent telescopic observations, including follow-ups by Hubble in 2007, 2011, and 2015, provided clearer views. However, nothing prepared the world for the incredible level of detail revealed when Webb turned its gaze toward the pillars in 2022. Webb's infrared capabilities penetrate the dense clouds of gas and dust that obscure much of the visible light, revealing structures that were previously invisible. The protostars, which appear as reddish spheres at the tips of the pillars, are newborn stars still shrouded in their cocoons of gas. Meanwhile, the curved, lava-like streaks visible in the image are actually the jets of energy and material that these young stars periodically hurl into space, shaping their surroundings. NASA recently released a combined view of the pillars, merging Webb's infrared images with Hubble's visible light data, showcasing the hot gas as well as the cool dust and nascent stars. This dual perspective offers an unparalleled glimpse into one of the most active star-forming regions in our galaxy, reminding us that while Webb's new images are stunning, the older data from Hubble still holds significant value in understanding cosmic phenomena. While Webb is renowned for peering deep into the universe to uncover ancient, distant galaxies, it has also been used to explore the objects closer to home, namely, planets within our solar system. Webb's recent images of Jupiter, the largest planet in the solar system, have provided us with a novel view of the familiar. Using 3 different infrared filters, Webb captured the gas giant in a light never seen before. This technique allowed astronomers to observe infrared radiation, normally invisible to the human eye, and translate it into visible colors. The resulting images were so detailed that even veteran planetary scientists were astonished. Webb's data reveals not only well-known features like Jupiter's Great Red Spot and auroras, but also delicate rings and tiny moons, including Adrastea and Amalthea. These features, often overlooked by other instruments, provide a fresh perspective on Jupiter's complex atmosphere and ring system. Lastly, Webb has turned its gaze toward the Serpens Nebula, a stellar nursery located 1,300 light-years from Earth. Webb's high-resolution imaging has allowed astronomers to detect previously hidden features in this star-forming region, including protostellar outflow jets, powerful gas streams ejected by newborn stars. What's fascinating about this discovery is that the jets all point in the same direction, a phenomenon that supports the idea that young stars may tend to rotate in a similar direction as their gaseous birthplaces collapse. This insight into the birth of stars would have been impossible to capture with previous telescopes. The Serpens Nebula's gas jets, which once appeared as blurred or indistinguishable features, are now revealed with stunning clarity, thanks to Webb's ability to penetrate cosmic dust and gas clouds. If you've enjoyed this journey through the stars, make sure to like this video, subscribe to our channel, and hit the notification bell so you never miss an update on Webb's next groundbreaking discovery. Stay curious, and we'll see you in the next cosmic adventure.